I'm going to show you a way to find the CDF of a transformation of a random variable. So in this example, we are given the distribution of x to be exponential, and we are given that it has a mean of 1. Okay, so we are saying that the expectation of x is equal to 1, but we know the expectation of an exponential random variable is 1 over lambda. So that implies that lambda must equal to 1. Okay, so then we have that x is distributed exponentially with parameter 1. Okay, now we're also given that y is equal to x minus 1 plus, which is the same as x minus 1 when x minus 1 is greater than 0, and 0 when x minus 1 is less than or equal to 0. Okay, and you can get that from that indicator function. Now also what we should notice is if x is distributed exponentially with parameter 1, then the CDF of x, so fx of x, is equal to 1 minus e to the negative x, and this is when x is greater than or equal to 0. Okay, so let's go ahead and approach this question now that we have all the information written out in a way that is usable. So when we're finding the distribution of y, what we're essentially doing is trying to find the CDF or the PDF of y. But because we know the CDF of x, we also know the PDF of x, but it'll be a lot easier to work with the CDF for this for finding the distribution of a transformation. So that's what we're going to do. So we're finding fy of y, and that's equal to the probability that y is less than or equal to y. Now what I recommend you do is to replace y with the transformation of the random variable that you know, so that you can eventually express this in terms of your original random variable exclusively, so that you know what the CDF is. So I'll show you what I mean. So we're going to let this equal to the probability that x minus 1 plus is less than or equal to y. Now, using the law of total probability and the definition of x minus 1 plus, we're going to expand this into the probability that x minus 1 is less than or equal to y, and that happens when x minus 1 is greater than 0, plus the probability that 0 is less than or equal to y, and that happens when x minus 1 is less than or equal to 0. Okay, so from here what I can do is I can re-express this, each of these inequalities, with x only on one side. So that gives me the probability of x less than or equal to y plus 1 and x greater than 1. Now for this side, it simply gives me the probability of 0 less than or equal to y and x less than or equal to 1. Okay, now what I notice is this comma here is actually like an intersection sign. So x less than or equal to y plus 1 and x greater than 1, that can only happen when x is between 1 and y plus 1. Okay, and this here, I know that 0 is always going to be less than or equal to y, because this is my output for y, either x minus 1 when x minus 1 is greater than 0. So that means this is always going to be greater than 0, or it's going to be 0. So y is always greater than or equal to 0, no matter what the input is for x. Okay, so this here forms everything. This is omega. Now this is now what restricts that omega. So we're taking the intersection of omega and x less than or equal to 1, which just leaves us with x less than or equal to 1. Okay, now what I can do here is I can rewrite this in terms of the CDF. So here we're going to have the probability that x is less than or equal to y plus 1 minus the probability that x is less than or equal to 1 plus the probability that x is less than or equal to 1. Now those two will cancel, and we'll just be left with this. So we know that the CDF of x, we wrote it up here, 1 minus e to the negative x. So we'll have 1 minus e to the negative, and instead of having x, we will put in this y plus 1. And we said this happens on x being greater than or equal to 0. So we can say here, when y plus 1 is greater than or equal. Okay, and then we also have the restriction from the definition of y, where y only takes on non-negative values. So here x minus 1 is greater than 0, so it's positive. And here y will be 0. So y then can only take on positive values or 0. So we can add to this, y must be greater than or equal to 0. Now this simplifies to y being greater than or equal to -1. But we must take the intersection of these two, y being greater than or equal to -1 and y being greater than or equal to 0, which means that we will just take the more restrictive inequality, which is y being greater than or equal to 0. And then, of course, when you're going to write it like that, you should also define on the other region, y being less than 0, the CDF is equal to 0. Okay, so I hope you enjoyed this video and found it useful. And if you did, please don't forget to leave it a like and subscribe to the channel. Thank you for watching.